Okay, we're back. We want to remind you about what we did earlier with our parallelogram into a rectangle construction. We saw that if we took this parallelogram A, B, C, D, that it could be made into a rectangle by drawing the perpendicular down here and cutting off this triangle and putting it over here. So therefore, the area of the rectangle is the same as the area of a parallelogram. Okay, if, same area formula, length times width. Though we're going to call them something different in the formula. It's going to call them base times height. So we'll look at that and come back to that in just a minute. And so here we are back again. We're looking at our parallelogram here, okay? And again, we have our segment lengths. Now we can put these lengths right over top here. So here's our measurement tool. So here we're going to click on the lengths, okay? So we'll click on that length and we'll put 445, so that identifies that as segment C. And we're going to have that length, which is 707, okay? Now, we know, and this is possibly quite easiest way to show, is that we can morph this thing into a rectangle, again, just by, clicking on it, uh, nice convenient points. That's a 4 by 7 rectangle, so its area should be, in fact, 4 times 7. 4 times 7, of course, being 28. Now, if we change that, we're going to change the configuration of that, okay? So as a rectangle, that's length times width. But so if we made that into a polygon, uh, just by clicking on these points, shading that area and coming back to A where we started, and then ask for the area, then the area of that is, of course, 28, right? But that's 4 times 7, length times width. But when we change this thing out of the rectangle into a more generalized parallelogram, it's no longer going to be this length of 5 times this length of 10, because that's 50, and our area here is 40. So obviously we have a change here. What we have to do is we have to find this height value, okay? And you can see that that height is 1, 2, 3, 4 units in height, 4 units in height. So let's just build that height so we can say that the height is equal to 4 times 10. That's the base times the height, the base times the height there, okay? So we're going to use the perpendicular tool here, okay? Perpendicular line, go from here down to here, construct the perpendicular, okay? And then, of course, we're going to use the intersection, come over here, intersect, just scroll over that and scroll over that, and then we can build that point right there, and we can measure that length, put that segment in, that segment between C and E, and we can measure its length. Okay, and its length is going to be 4. Okay, and that's the length that we need in order to find that, in order to find the area. So it's the height, which is the distance between the two parallels, times the base. Okay, all right. So now, of course, we can change that configuration in many different ways. And what I want to do is I want to come back here and I want to hide that line right there. So there, you're just looking at that segment. Now, there's also another height and another, uh, which is the height between the two parallels going in this direction. So now, again, the thing is going to be that this is going to be consistent regardless of how I move this thing around. So if I move this thing around, okay, that height always times that base of, which is 1118, which is the same as base down here, is going to be the area of the parallelogram. Okay. Okay. Back. I want to show you a way in which the area of this can be computed with um, the GeoGebra. So we know that the height here is CE, okay? And so that the area would be 5.19 times 11.18 as it stands here. So, and of course that's going to change, and this was the area which is consistent 58, but that's not the area that wasn't found by formula, the base times the height. That was found by shading in and it counting out and computing that area, okay? So now let's do a text box. Now here we're just going to insert a text box right here, okay? And there's nothing done until we click on down in our workspace here, and then here comes the text box, what we want to put in. Now we're going to actually sneak a formula in here as well as some text. So we're going to put in quotations, quotes, quote, area equals, and we're going to end quotes. Now we're going to put a formula in, which is going to be indicated by a plus sign here, okay? Then we're going to put in a bracket, and then we're going to put in what we need, what pieces we need to multiply in order to compute the area. Now, pieces we need to multiply, of course, are the base times the height. Now, the height here is this segment, which is called segment I. As you can see in my figures, it's called segment I, which is of length now 5.19. So I'm just going to put in I times, with the asterisk here, times the base, which is 1118, which is CD, um, which is either which is also segment A down here, which is 1118. So I'm going to put in I times A, and I'm going to close the formula, and it's going to report to me that the formula of the area there is 58 with that formula. And so I'm going to click on OK, and it's going to come up here, and I can then, I can then change that in size if I want, color or anything else. Okay, so that is the area right there. Okay. Okay, so now we know that the area of the parallelogram is the base, which we measured over here. Okay, base AB times the height, which is the segment length between the two bases. Okay, now so if I were to use the base here of AC, then I would have to draw the height to AC. Okay, now in some cases that height might extend outside. So what I'm going to do is kind of like construct this in such a way. We're going to actually come and we're going to hide this segment, this height, which is 669. Okay, is that what it says it is? Okay, and we're going to hide that segment CE, right? And we're going to build the other segment. So we're just going to hide that one for now. That's the wrong one. Okay, and we're going to construct the perpendicular. So let's construct the perpendicular again, right here, perpendicular from here to here. Okay, so there's that perpendicular, and that is going to be, now again, we're going to want to find that intersection height, or that point of intersection. So we're going to click on our intersection tool, come scroll over that segment, scroll over that segment, and then build our, locate our point of intersection right there. And then we want to measure that length, which is BH. So we're going to draw the segment there, segment from that point to that point, okay? And come back now and select and hide this line. It seemed like the line was not hidden. Let's draw that segment again. Draw the segment again. And give me a little hard time here. Segment constructed. Select this line. Let's not show that line. That line seems to got in there for some. Okay, so now this segment here, BH, and this line segment here, their product should also equal the area. So we're going to compute the length of the, ask for the length of that segment, 803. We got the length of this segment. Okay, so now we'll build another formula again. Area formula here. Again, we're going to put in quotations, quote, area equals, end quote, space, plus to indicate we're putting in an operation. And now we want this new segment 803, which is looks to be segment M. Okay, we can come over here and verify that that's segment M 803. So we're going to put M times asterisk this segment here, which is segment C at 8.58 C, and close, and then that's also going to give us our formula of 6886, and that's going to be regardless of how we change this. Okay, so we can find the area of the parallelogram with the formulas base times the height, where the height is the distance between any two sets of parallels. So we've got the height CF here with the base AB, their product, and we've got the height, our new height here, HB, with the base AC. So we can use either one of those, okay, to find the area, and it will always be the same. Okay, there you have it.